Okay, guys, let's go ahead and get started. So last time we talked about linear search, so searching for an element X in a list. Um, so when describing that algorithm, the list that we were concerned with just had distinct elements in it. It did not have any ordering to the elements. However, when a list has ordering on it, we can improve the runtime for a search algorithm with, from linear search. We can improve that with what's called binary search. So let's go ahead and say new file, call this binary search.py. Okay, so let's go ahead and describe this. So, okay, binary search. Okay, so binary search works with an ordered list. So um, when a given list is ordered, uh, maybe not ordered, but when a given list is um, strictly increasing, we can improve linear search with binary search. Okay, so this algorithm works by splitting the list into two smaller lists. It then compares the largest entry in one list to the element that we're looking for, that we are searching for. Okay, so let's go ahead and kind of play around with this idea over here in the console. Okay, so let's make a list. So L is equal to 1, 2, 3, 5, 6, 7, 8, 10, 12, 13, 15, 16, 18, 19, 20, and 22. Okay, so notice that this list is strictly increasing, right? 1 is strictly less than 2, which is strictly less than 3, so forth and so on. And suppose we want to search for X, which is equal to 19. So we want to find 19 inside of L. We want to find the location of it. So what we can do is we can split this list down the middle. So how long is this list? So this list has 16 elements in it. So what we can do is say lower is equal to L, and we can use this splicing to 8. This is a 1, 2, 3, 4, 5, 6, 7, 8. So we should include that 10. So let me just check something real fast. Yeah, so notice that this is precisely this list right there. So this is just splicing. It's from the 0 index up into the 8th element here. So, okay. So we can say lower is equal to this lower list. And then we can say upper is equal to the other half of the list. So from 8. Let me just make sure the splicing. And so this list right here is the other half. See that? So we'll say that upper is equal to that. All right, so here is our lower list right here, and here is our upper list. So we've split this list into two sublists called lower and upper. Okay? And again, we're searching for X. Now we know that our original list, L, was in strictly increasing order. So we know that if we split the list in half, right, the last element of lower is the biggest element in lower, right? So if I do lower -1, which is the last element, we get that it's 10, which is the biggest one. So we know that lower cannot contain X, right? Because so lower -1, is that less than X? True. And since the last element in lower is the biggest one, we know that X cannot belong to the list lower. So that means that X must be in the upper, right? If it's going to exist in this list somewhere, it's going to be in here. Okay, so what we can say is now we can just maybe change our list to say L is equal to upper. And maybe we don't want to do that just yet. So now we need to do the same thing here. Let's split upper into a lower and an upper list. So lower is going to equal, so if there's how many things in here? So 8, right? So we want to divide that in half. So we're going to say upper up into 4. And then upper is equal to upper 4 to the end. All right, so now we've split upper into these two lists right here, right? So then we compare the lower, right? So lower -1, is that less than X? True. So then we know that X is not going to be in the lower one now, so we check upper. So let's split the upper one again. So upper has 4 things in it, so then I'm going to say lower is equal to upper up into 2, if we split it in half, and then upper is equal to upper 2 to the end. All right, so we now have these two lists. And now let's see, lower -1, is that less than X? False. So now we know that we have to search inside of here, inside of the lower list. So we're going to say, so lower has 2 things in it. So we're going to divide that in half and say upper is equal to lower 1 on, and lower is equal to lower up to 1. All right, so now we do the same thing again. So lower -1, is that less than X? True. So then we then move to upper, which happens to have 19. So when we exhaust this process of dividing in half, and always checking the last element in the left-hand or the lower list, eventually we're going to get to just a single number, right? If X is in that list, it's going to be that single number. Okay, so this is the general idea, that we divide, and eventually, if the X is in the list, then we will find it. Okay, so what does the pseudocode look like for this? So, okay, so name, binary search, input, x, oh, sorry, let me just fix this real fast. Input, so x, which is some number, and then a1, a2, dot, 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 an, a list of strictly increasing numbers. Okay, and then the output is going to be location, which this is a integer location, integer index of the location of x in, I'll call this list L, and L, or -1 is not found. Okay. All right, so what does the algorithm look like? Okay, so so here we were slicing and slicing and slicing. We found x, right? But we didn't find the index of x. So in order to find the index that corresponds to x in the list, we're going to have to be kind of clever here. We'll say something like I is equal to 1, I is equal to 1, and j is equal to n, if there's n things in the list. I'll go ahead and try to, no, I'll get to that later. So what we're going to say is, while I is less than j, well, actually I should probably just tell you what these things are here. So I is going to be the left endpoint, okay? And so left endpoint of the search interval in the list. And then here, j is going to be the right endpoint of the search interval. Okay, so while I is less than j, we're going to set m, which is the midpoint. So remember how I was finding the midpoint and then separating the lists over here? So m is going to be equal to the floor of I plus j divided by 2. Okay, so recall the floor is the largest integer less than or equal to x. So so if your integer was 1.2, the floor of 1.2 would be 1, right? So it just rounds down to the nearest integer. Okay, so this is the midpoint of the current list. Okay. So then now we're gonna use this, right, to split the list into 2 lists, and then we need to do the comparison just like we were doing over here. So we're gonna say if x is greater than a m, base of m, we want to say I is equal to m plus 1. Else, j is equal to m. Okay, and then eventually, we're going to break this while loop. And then we want to say if x is equal to a sub I, return location equals to I. Else, return location equals to -1. So we didn't find it in that case. So let's kind of go through this with our list over here and see why this would make sense. We're going to have to adjust our indices here because Python starts with index 0. So I'm going to say I is equal to 0. And then length of L, how many things are in there? 16. So then I'm going to say J is equal to length of L minus 1. So I'm just shifting these indices over here. So instead of writing 1, I'm doing 0. And instead of n, I'm doing n minus 1. All right, so here's I and j. So let's just check this condition real fast. So I less than j, true. So we're in this while loop, okay? So let's set n equal to the floor. Surely there's a built-in function, the floor. Yeah, it's just floor, so I thought. Oh, math. All right, so we're gonna have to import floor from a module. We can do that, so we can say from math import floor. So this is just the math module. It's in the standard library, and you can have access to the for function. So I'm going to now use that to make my m. So n is equal to the floor of I plus j divided by 2. Okay? So we see that n is 7 here, right? So now let's check a sub n, or L sub n, I guess, here. So is x, which is 19, so is x greater than L of n? True, right? So then what we're going to say is now I is equal to n plus 1. I is equal to n plus 1. Right? So notice I now, I and j. I is 8, so 0, 1, 2, 3, 4, 5, 6, 7, 8. So now we're starting here in the list and going to the end. Okay? So is I still less than j? True. All right, so we're still inside this while loop. So we're going to say n is equal to 4 of I plus j divided by 2. Again, all we're doing is we're taking the middle point of indices I and j. That's what divided by 2 and taking the floor is. So now n is 11. Okay. So let's see, is x greater than L at n? True. All right, so we're going to say I is equal to n plus 1. All right, so now I is 12, so we're scooting all the way down this list now. So is I still less than j? True. Okay, so just do it again. N is equal to 4, I plus j divided by 2. N is now 13. Okay, so is x greater than L of n? False. All right, so this condition is not met, so the else is that j is equal to n. So j equals to n. So now look at J. J is 13, I is 12. They're getting closer to each other. I is still less than J. So we're going to do this one more time. We need to make a check here. All right, so that's true. So we're going to say I is equal to n plus 1. Now is I less than J? False. So now this while loop has been broken. And then we check, does x equal L sub I? It does. I should have done x double equals L sub I. Okay, so that's how this works. So now that we've kind of seen that we're constantly shifting back and forth, checking left, right, left, right, left, right, and adjusting our indices, we can program this. So we can write this as a function, binary search. So it takes x and a list L. Okay, so I is equal to 0, J is equal to the length of L minus 1. Okay, so while I less than J. Oh, we're going to need the math module in here as well. So from math import store. Okay, so n is equal to 4 I plus J, all divided by 2. Ignore that little error there. So, okay, so if x is greater than L at n, it's equivalent to splitting the list. So we're going to say that I is equal to n plus 1. Else, J is equal to n. Okay, so that will take care of the while loop portion. So now we're going to say if x is equal to L of I, return I, which is the location. Else, we didn't find it. Return -1. All right, so we should have that in there. So let's do binary search. By the way, I ran this script, so I have access to that function. Binary search. Let's look for 19 in the list L. If we do L of 13, there it is. Okay, we could also say, let's search for something that's not in there, like 23 is not in there. So -1 means it's not there. So maybe 4 is not in there either. But 5 is. And if we look at that index, there's 5. Okay. So this is binary search. Now, for those of you that will be on the job market soon, or at some point in the, coming up, I wouldn't be surprised if in a coding interview, you might be asked to program binary search, or you might be asked to program linear search. Right? These are kind of standard, simple questions you could get during an interview that all of you should be prepared to answer on your own. Right? So just because I'm describing the algorithm to you and showing you and giving you the code doesn't mean that you shouldn't try to program it on your own, just because you'll need to at some point, likely. Right? Okay, so that will be it for our searching algorithms. Um, and I think that'll be it for today. Next time we will look at sorting algorithms, which is, again, these basic algorithms are common questions in interviews. So please don't just watch me program them yourself as well. All right, so that'll be it for today. I will see you guys next week.
Professor?
Yeah.
I just had a quick question. I guess regarding just the schedule for the rest of the semester. When could we expect the next test?
Let me look at the calendar real fast. So probably the first week of November.
Okay. All right. And then I guess if we're doing a lot of algorithm coding in Python, could we expect that our test will include some coding portion, or will we be writing out the code?
You'll be writing out the code.
Okay.
In the question should be something like write the pseudocode to solve some problem I give you, right? So write the pseudocode, part A, and then part B, write the Python code for that same problem.
Okay. Okay. Thank you, sir.
Mhm. All right, any other questions? Also, the algorithms homework I'm going to extend to be due at the end of the month and not on the 25th. Okay. All right, I will see you all next week.